Hey guys, in this video, we're going to be talking about geometry and linear measure and precision. What is that? So in the last video, I talked about geometry fundamentals to get you started. We talked about lines and points. In this video, I may mention some segments and how to measure those. When you have a segment instead of a line, a segment has 2 points. And between those 2 points, you can measure those points. And that's what we're going to do. So let's get started. So say, for instance, I have a line. Remember from previous lessons, a line is represented by 2 arrowheads at the end. But on the line, there are points. Let's say points A, B, and C. Now, if we're mentioning segments, a segment looks like a line without the arrows with a point at each end. That's what a segment is considered to be. So you want to make sure you distinguish between the two, between a segment and a line. So when I look at this line with these points, let's just say the distance between these points are 4.4 centimeters. So between A and B is 4.4 centimeters, and between B and C is 4.4 centimeters. So if you see an equation like this in geometry that says AB, segment AB plus BC, so we have AB plus BC equals all from A to C, the segment A to C. See that? So A to C is from one end to the other. If you were to break that up, you would have AB plus BC equals all of AC, which is this. So with that being said, let's plug in some numbers to see if we can find out what AC is. So AB is 4.4 centimeters. BC is 4.4 centimeters. The two of those added together give us segment AC. So when we add those together, 4.4 plus another 4.4 gives you 8.8 centimeters equals AC. Fairly easy, right? Pretty simple, pretty easy. Okay, let's try another type of geometry problem when it comes to linear measure and precision. All right, for our next problem, let's just say we have a segment with points D, E, and F. And let's just say the distance between E and F is 2 3/4 inches. And then let's say that the distance between D and F, which is here, let's just say that's 11 inches. So you notice in this situation, I'm giving you the entire length of the segment D to F, and then I'm giving you a piece of a segment E to F, which is 2 3/4 inches. So what if I wanted to find the distance between D and E? So based on what we're seeing, DE segment plus EF segment equals DF. So you want to make sure that you can understand that and see that from a visual standpoint. D and E, which is this section here, plus this section, E and F, gives you all of this, which is D to F. Okay, so now DE is what we're looking for. So we'll say plus EF, which is 2 3/4 inches, equals all of DF, which is provided, which is 11 inches. So we don't know what DE is. What we can do is just say this is still DE. We're going to solve for DE. So in order to solve for DE, we need to, when looking at a regular equation, we want to get DE by itself. So this DE is added to this 2 3/4 inches. So in order to find out what DE is, we need to go ahead and just minus the 2 3/4 inches on both sides. So we're going to do minus 2 3/4 inches minus 2 3/4 inches. And why do we do this? So first of all, and you've learned this in previous lessons, but I'm going to keep reiterating it. When it comes to an equation, this equal sign is basically saying the left side equals the right side. So if you change it in any way, in order to keep it equal, whatever you do to the left side, you also have to do to the right side. So from a visual standpoint, we see DE plus 2 3/4 inches. We want to get DE by itself because that's what we're solving for. So we want to get rid of the 2 3/4 inches from the left side. If we do that, in order to keep the equation equal, we have to minus it also on the right side. So once we do that, plus 2 3/4 inches minus 2 3/4 inches cancels each other out. So on this left side, you're left with DE equals, and then on the right side, you have 11 minus 2 3/4 inches. Now, how do we put these in like terms? So we could also say 11 is also, let me get rid of that. We could say that 11 is also 10 4/4. So 4/4 is 1, so 10 4/4 still gives you 11. So we could say minus 2 3/4. So now we have these numbers in like terms. So we say 10 minus 2 is 8. And then we have 4/4 minus 3/4. So we keep the denominator the same since they have the same denominator. 4 minus 3 is 1. So your answer is 8 1/4. And we keep our measurement 8 1/4 inches. So you may be given a problem where you're given the small portion and then the entire portion, and they need you to find the missing portion in that piece. So I hope this helps. Let's try another type of geometry problem when it comes to linear, measure, and precision. Okay, for this last type of problem that we're going to go over in this segment, no pun intended, segment. Say you're given a segment, Q, P, R. And let's say in this instance, you're given the numbers as a variable. So you would still need to find an answer even though you found the numbers within the variable, if that makes sense. So say, for instance, if this is, you're given 2y here, and you're given 20 here. So 2y represents the distance from Q to P. 20 represents the distance between P and R. But then when I give you this entire distance, this could be, say, 3y plus 1. All right? So let's do this problem similar to what we've done before in the previous sections or in the previous examples, and we'll go from there. So from a visual standpoint, we know that QP segment, remember a segment has two lines, two points, two endpoints. So we know that QP plus PR equals QR in this instance. So now let's fill in the blanks. So we know QP is 2y. We know that PR is 20. and we know the total QR is 3y plus 1. So now all of a sudden this becomes a regular equation. So what we need to do in this instance is combine like terms, and then we need to solve for y. But once we solve for y, that's not the end. We need to take y and add it back in to these figures to find out what they are. So first, let's solve for y. So it looks like this number is bigger, so we want to keep y positive. So I am going to minus 2y on both sides in order to combine y's. Once we do that, the 2y goes away. On the left side, we have 20 equals, and then 3y minus 2y is just 1y, or y plus 1. And then now if I want to solve for y, I just minus 1 on both sides. 20 minus 1 is 19. 1 minus 1 is 0, so we're left with y. So y equals 19. But we're not complete yet, so if we're looking for segment QR, that is equal to 3y plus 1. So what we have to do now is add in the y in order to find out that segment. So this would be 3 times 19 plus 1. So if you come off to the side, 19 times 3 is 57. So you have 57 plus 1, which equals 58. So that is your answer for QR. We also see that QP is 2y, or in this instance, 2 times 19. Now you could either use a calculator or come off to the side. 2 times 19, 38. 2 times 9 is 18. Carry the 1. 2 times 1 is 2, plus 1 is 3, equals 38. So you see in this instance, you may need to go a step further if you're given a variable within the answer. Find the solution to the variable and then come up with your answer. So I hope this helps. I hope this gives you an example in geometry of what linear measure and precision is. We're just going to keep building on everything that we learn. So in the next section, we're going to keep taking it a step further in each section. So I hope this helps. If this helped you, send it to someone else, and we'll see you in the next video.